the study guide video. Chapter 4. Let's do this.
Alright guys, let's go. So we have to prove this triangle. These triangles are congruent. I think there might be a mistake on this one. Let's go check it out. Okay, first of all it says AB is parallel to CD. And I'm sorry, they're not parallel, they're congruent. I'll start it out with a mistake myself. And then it says BC is parallel to AD, so these are parallel. Okay, prove the triangles are congruent. So the first thing I want to do is I want to mark everything I have. Well, I'm going to have this as a congruent side right there, and then these are the two alternate interior angles. So right now, this would be angle side side and angle side side. So this is actually a mistake. These are supposed to be AB and CD as well. So that is a typo right there. So these aren't actually supposed to be anything. These are supposed to be the parallel lines. So I am sorry, but we're supposed to have side angle side. So I'm going to redraw that picture for you, what it should look like, because it got all messed up with that one little piece. So first of all, it says AB is congruent to CD, but then they're also parallel, so that makes these the alternate interior angles, and then this one right here. So we have right here you can see side angle side congruency and side angle side congruency. So we're going to do SAS for this. Okay. So first thing we're going to do is we're going to get both of our given off on the same step. AB is congruent to CD, and AB is parallel to CD. And that's given. Within that, we were able to prove one side, and then we proved that those angles are congruent. ABD and CDB, this is alternate interior angles theorem. So that's our other angle. Then we have our other side here, BD is congruent to BD, that's reflexive property. And then the triangles are congruent by side angle side. Okay. So if that one didn't have the typo, it would have been a really nice one. Alright, here we go. AC bisects BAD. So BAD is this full angle here, but since it gets bisected, it gets cut into two congruent angles. So these two angles are congruent. And then BCD is this whole angle, and it's getting bisected. So we actually have these two angles are congruent as well, and then they share a side. So this looks like angle side angle. And you can see even in the proof they show that. So given is the AC bisects angle BAD and angle BCD. Definition of angle bisector. So we got to prove one of these angles. So I'm going to go BAC. So angle BAC is congruent to angle CAD. Definition of angle bisector. So that shows my one angle. This looks like reflexive property, so we're going to save that AC for AC, that one. So we're going to do the other side. The pink angles, BCA is congruent to DCA. And that's by actually the same exact reason. Definition of an angle bisector. And so that's another angle. And then our congruent side there is CA is congruent to CA. And that's by reflexive property. Okay, and then last but not least, we just write the triangles. Get all three pieces. Write the triangles are congruent. ABC is congruent to triangle ADC. And there you go. All right, state whether what theorem you'd use to provide a congruency statement. Okay, so first one here we have vertical angles here. So that's going to be angle angle side. So angle angle side, and so J is going to match up with L. K is going to match up with K, and H is going to match up with, L's, I think this was supposed to be H right here. That's going to match up with L. That's really confusing. M, I'm sorry. Second typo we found. So that's supposed to be JKH. Alright, this is side, side, side. They share that side, and we have the three sides. Q is between 1 and 2 congruent marks, so between 1 and 2 congruent marks is in. And then let's see, we have P is going to match up with between the 2 and the 3. The 2 and 3 would be the R on this one, so these are kind of reversed PR. And over here we have a set of vertical angles. That's going to be angle side angle. Whoops, goes right there. And Z is going to match up with C, Y is going to match up with B, and then A will match up with A, CBA. A couple more. Whenever we have parallel lines, we should be looking for our, let's spell, alternate interior angles right there, and another set right there, so that's going to be angle, side, angle. And L is going to match up with N, and N is going to match up with L, and M is going to match up with O, NLO. Here we have angle, angle, side, and angle, angle, side, so those are pretty basic. And T is going to match up with Q, W is going to match up with R, and X is going to match up with S. This is angle, side, side, and angle, side, side, so that's S, so that doesn't work, so it's not congruent. Okay, and use the diagram to tell why each statement is true. So H and K are congruent. That's by alternate interior angles theorem. So we'll just mark that. H and L and K and L, those are our vertical angles. Theorem. And the triangles are congruent. It's going to be angle, side, angle. Name the angle or side that corresponds to the given part in this here. So this is our congruency statement. So QS is the back. So Q and S is the front and last letter. So it's going to match up with MO. Angle O matches up with S. NO is the last two letters. So it's going to match up with RS. And Q is the first one. So it's going to match up with M. So corresponding parts of congruent triangles are congruent, basically. So here we draw two triangles, ABC, DEF. I use them in the same order. AC is congruent to DF. BC is congruent to EF. And then B is congruent to E. Are these two triangles congruent by side, 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 or side, angle, side? No, they're not. They're actually angle, side, side, so that doesn't work. If no, oh, the lights went out. They went dark.
I love the dark.
Okay, so if no, what additional information mean? Okay, so what we need, we could do two things. Need AB is congruent to DE for side, side, side. That would work. Or we could show that angle C is congruent to angle F for side, angle, side. Okay. All right, guys, that's pretty much it. Good luck. Thank you very much. Hope you do well on the quiz, and that's it.
Hippopotamus.